Okay, in this short video, we're going to talk about how to use Boolean operations with C. So this is a 4-part video series, and in this part we're just going to talk about the concepts, the basic operations that you need to understand at a conceptual level. Okay, so let's take a look at what the basic operations are. There's 4 of them. We have AND, OR, exclusive OR, and NOT. Okay? Now, the cool thing about these basic operations at a conceptual level is that they fit English perfectly. One of the few things in computer science where the terminology is intuitive and easy to remember. So let's explore these 4 operations. And we're going to do it using an example. Stacy wants to apply to a program, but in order to apply to this program, she must meet certain eligibility requirements. So before we get into the requirements, let's talk a little bit about Stacy. Stacy is a junior, studies CS, so they're a computer science major, has an A GPA. I guess we should put A. Let's use numbers. So we will say a 3.9 GPA. And Stacy goes to SJSU. Okay? Now, if we look at the program's eligibility requirements, let's look at different requirements using these different operators. So each eligibility requirement is going to make a statement, and it's going to talk about 2 potential characteristics that may be true or false. Let's say the first statement, we'll call it S1, is a graduate student. So in order for S1 to be true, the student must be a graduate student. And the second statement, S2, is a GPA of greater than 3.5. Okay, so S2 is that they have a really good GPA. Okay, so let's say the first requirement says you must be a graduate student, S1, and you must have a good GPA, a GPA greater than 3.5. Okay, now, does Stacy meet these 2 requirements, right? S1 and S2? No, she does not, right? If the requirement is S1 and S2 for eligibility, Stacy is not eligible. However, what if instead of being an AND, it's an OR? S1, graduate student, or S2, a good GPA. Well, Stacy's not a graduate student. However, Stacy does have a GPA that's greater than 3.5. Since this is an OR, it can be one or the other, then Stacy would be eligible if this were the requirement. Let's look at the requirement in terms of XOR. So XOR is the exclusive form of OR. Now, it would be really nice to be able to say XOR in language when we talk to each other. But in order to say it in English, we have to say a lot of words. So exclusive OR means S1 that either S1 or S2 are true, but not both. So it's exclusive, like exclusive contracts. An exclusive contract would only go to one party. So with exclusive OR, only one of the things may be true. If both of them are true, then it violates the condition. So exactly one of these two things must be true for the exclusive OR to be true. So, is Stacy a graduate student? No. Does she have a GPA greater than 3.5? Yes, Stacy does. So, exactly one of these things are true. Stacy would then be eligible for the program if this were the case. Now for not only operates on one thing. So let's put a not S1 here, right? So is Stacy not a graduate student? Right? Stacy is not. So she would be eligible if this were the case. Okay? So let's change the statements a little bit, the truth values of these statements, just to see how things may change. Okay? So let's say the condition is no longer graduate student. Let's say the condition is undergraduate. Or let's say, undergraduate. Undergraduate. Okay? So let's reevaluate these statements then, or these eligibility requirements. If it's S1 and S2, Stacy is an undergraduate and has a good GPA. So Stacy would qualify. Let's look at the OR. Is Stacy an undergraduate or has a GPA greater than 3.5? Yep, she does. She has both, which satisfies the OR, right? Now let's look at this third one. Is Stacy either an undergraduate, exclusive, or has a GPA greater than 3.5? Well, she has S1. She also makes S2 true. So both of them are true. So we don't have the exclusivity, right? Both of them are true. So if this were the case, Stacy would not be eligible. And then finally, is Stacy not an undergraduate? This is also false. Stacy is an undergraduate. Okay, so what we see here is the not flips the truth value of the statement. So if it's not true, then it's false. And if it's not false, then it's true. Okay, for exclusive OR, it has to be one or the other being true, but not both. Okay, so let's look at one more case here. So let's say the requirements S1 is a sophomore. And S2 is a history major. Okay, so let's again look at these requirements. Is Stacy a sophomore? No, S1 is false. And is Stacy a history major? No. So if both of them are false, that means false. Actually, we knew we weren't going to make it right when S1 was false. Now let's look at the or. Is Stacy a sophomore? No. Or a history major? No. Also false. Let's look at exclusive or. Is Stacy a sophomore? No. Exclusive or a history major? No. Stacy is neither one, therefore she does not qualify. But what if the eligibility requirement is that Stacy is not a sophomore? She is not a sophomore. She is a junior, so she would qualify. Okay? So hopefully this gives you some good insight into how, conceptually, how these Boolean operations work. Okay, in the next videos we will delve a little bit more into how we do this in C, how we use them in C in both logical ways, like exactly like we're using here, or at a bit level. So if we look at the individual bits of numbers and operate on those.